Good morning everyone. So today we'll be discussing the continuation to our last session, that is IUPAC nomenclature for organic molecules. Right now, so there we have discussed from very scratch, from very basic I have started discussing about IUPAC nomenclature and what are the basic rules that we need to know while writing the IUPAC nomenclature, right? And a few more things to be discussed. Then after that, today we will be continue our session till understanding about basic chemical reactions and their approaches. Okay, so yeah, so let me give you little more clarity on IUPAC nomenclature, then we will move for the organic reaction, like basic reactions. Okay, it's not completely the complete organic reactions, but basic approach towards organic reactions. Okay, right. So now look at this. In the last class, if you have seen, I have shown you these structures and I asked you to write their names. What is the name of this compound, I asked you, something like that. I have given different structures, right? So if you remember, so I have made some structures something like these, okay, like these, and I have inserted a alkyl group over here. Okay, then next here I am saying one more thing. What if I insert one more group over here? So where you should start numbering it. Okay, so how can we write the name for these kind of molecules? Okay, so now remember, when you are writing the name of a compound, first of all you need to identify the longest parent chain. Longest chain is called parent chain. Now in this compound, the longest chain is the cyclic ring. If you observe, how many carbons are there? 1 2 3 4 5, like that 5 carbons are there right now. So now what happens to these extra things, like this, like line you are seeing now, that is nothing but this is a methyl group. Okay, like this you can write methyl. Okay, if I have written one line means it is methyl. Okay, this is methyl. Okay, if I write one more like this means one carbon and one more carbon here. Okay, 2 carbons are there means it should be called as ethyl. Okay, like that you write the names. Okay, let us write the name for this molecule itself. Okay, so I am keeping ethyl as it is. So how can you write the name for this? Okay, so now while writing the name, we need to number these substituents also, like these branches also. So it means from where we should start numbering? Yeah, always start numbering from the functional group, the principal functional group, if anything is there in the given compound. So we have a pi bond here now, so this is now our functional group. Okay, now from where I should start? Either I should start from here or from here or then here. So tell me, see, always remember the substituent should get minimum number. Okay, once again, first identify the principal functional group, start numbering from it, and your substituent should get minimum number that is possible. Okay, so now our substituent, like functional group, is at here between these 2 carbons, so I can number from here or here. But what I told you, the substituent is on this carbon, so give number 1 for this. Okay, this is 1. Okay, after that, so this is 1 I am saying. Then after this, what you can do is, you don't go this side, complete the numbering for alkene carbons. Okay, 1 2, okay, come this side only. Don't go like, yeah, this is a branch, it should get minimum number, so don't write it here, because we need to finish our numbering to this alkene carbon first. Always remember this is, okay, 2 3 4 5, okay, that's it, 5 over. So now how can I write? So what is our parent chain? Pent. Okay, cyclo, because it's a cyclic ring. So first you write root word or word root as pent. Okay, after writing this root word, what are the prefixes we have? Okay, so since compound is cyclic, so you can write cyclopent. Okay, after that, this is primary prefix. What is the secondary prefix? That means here you need to write. What are the branches we have? One is ethyl, another one is methyl. So now in alphabetical order, which letter comes first? Ethyl. E comes first, then M, right now? So right, that's why you first mention ethyl, then methyl. So you can write 5 ethyl, next 1 methyl, cyclopent, 1 ene, cyclopent ene you can directly write, or 1 ene you can write. So this is how you need to write the name. Hope the discussion is clear. Yeah guys, if this is clear, please mention clear in the chat box. And just for your clarification, I will be giving you one more question over here. You just answer me in the comment box. Okay, so what I am writing here is, Now I have increased the cyclic chain ring size. Okay, yeah, ring size is increased. Now here I am placing a double bond. Okay, then here ethyl group, okay, and then here methyl group, okay, and here methyl group. Okay, so this is the compound I have mentioned. You just name. Okay, so you just give a name for this compound. Okay, based on your understanding, whatever the way you have followed the session, you just answer based on that. Okay, so if you haven't watched yesterday's session and you are not aware of IUPAC nomenclature, anything about a basic organic chemistry, I suggest you to watch my previous 2 sessions that I have made specifically for covering basics. Okay, if you are a class 10th moving for 11th, please watch it, or 11th 12th studying student who are like having some confusion with the basics, watch it. Okay, that's it. Yeah, let's move forward. Just write the name for this and mention in the comment box. Yeah, so now I told you there are different functional groups in the given organic compound sometimes. So how can you write that compound name? Okay, so now we need to prioritize the given functional groups. Okay, what we need to do? We need to prioritize a given functional group. So who is more priority functional group here? So carboxylic acid, next sulfonic acid, next ester, next acid halides, amides, okay, next cyanides, aldehydes, ketones, next alcohols, thiols, amines, here alkenes, and least is alkynes. Okay, right, let us see one example based on this. Here I will be writing a structure. Okay, so here I have inserted aldehyde. Now at this position one chlorine, and at this position one OH hydroxy group, and at this position a double bond. Okay, like this. See, it is nothing like there are only limited number of compounds. No, you create any number of compounds, you can write the names just by following IUPAC nomenclature. So that's why, because in everyday life there are many number of compounds like going to be synthesized. Okay, we need to know their names. So by following IUPAC nomenclature, whatever the compound it is prepared, yeah, we can give a particular name for it. Okay, so that is that much important IUPAC nomenclature is in future also, not for just for classes or learning for exams, not like that. It will be useful for anywhere. If you have chemistry in your life, then definitely it will be useful. Yeah, so now look at this. So from where I should start numbering? Yeah, you need to start from the priority functional group. Out of this, who is priority functional group? See, you have aldehyde here, right? So aldehyde first, then next hydroxy groups. So it means first prioritize to the carbon which is having aldehydic functional group. So this is the one. So 1, okay, next 2, 3, 4, 5. That's it. Okay, right. So now at second position we have chloro. At third position we have OH group means hydroxy. Okay, yeah. One more thing. See, if OH group is taken as suffix, sometimes might be OH group only principal functional group. In that case, OH should be called as ol. It means suffix should be ol. Okay, if we are writing this in the prefix forms, you should mention it as hydroxy. What you should write? Hydroxy. So now what is the name of this compound? You tell me. Hydroxy, here H, hydroxy H, chlorine C. So which comes first in alphabetical order? C. So that's why 2-chloro. What I am writing? 2-chloro. Okay, 2-chloro. 3-hydroxy. 3-hydroxy. Next, how many carbons are there? 5 carbons. Okay, hydroxy. Pent. Okay, at fourth position double bond is there. Pent. 4-ene. What is that? Pent 4-ene. Okay, 4-ene, and first position aldehyde group now. So for aldehyde, when you are writing in the prefix format, what I am saying, when you are writing in the prefix format, we need to use them as aldo. okay, aldo or formyl, sometimes oxo also it will be, we will see them in the examples, but here we are saying this as a suffix because principal functional group as per the priority aldehyde is there in the given compound. So the compound name should end as al, like 1 carbon methanol, 2 carbons ethanol, okay, butanol, here 5 carbons na pentanol, okay, so 4 position double bond pent 4 ene 1 all, or you can simply write it as 1 all, or you can write it as pent ene all also at the end, okay, both of them are perfect, okay. I hope the naming of this compound is clear, right? Now just follow the same way and try to mention the name for the given compound here. Yeah, can you write the name for this? Write the name for this. This is an example question. You just try it and tell me your answer for this in the comment box. Okay, right. Let's move forward then. Yeah, so these many names, these many functional groups we have, right? So the last slide we have discussed about aldehydes. Aldehydes we have discussed, if you have seen the last slide. Okay, so for aldehyde what I told you, for aldehydes there is a functional group mentioned like this CHO, and what is the prefix I told you, it should be written as formyl. What is it? Formyl, or we can also say it as oxo. What you can say? Oxo also. So sir, when we need to use the formyl and when we need to use oxo means if the parent chain, in the parent chain if you are counting the carbon of aldehyde, then use oxo. If you are not counting, use it as formyl. Okay, right. Now suffix, what I told you, again if you are not counting the parent chain carbon, I mean aldehyde carbon in the parent chain, call it as carbaldehyde. If you are counting the carbon, then you can call it as al. Okay, so give one example for this also. Yeah, I will be giving you here. See, CH, 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 CHO, CHO, CHO. This is a previously asked question. Okay, like this they have mentioned. Like this they have mentioned 1, 2, 3, 4. Like this they have mentioned and asking for writing IUPAC name. So how can you write this? So if you observe, if I start numbering from here 1, 2, 3, 4, 5, see all the functional groups are same here, aldehyde functional groups only. I cannot number like this. Why? Because this is also aldehyde, this is also aldehyde with equal purities. How can I miss this middle one? So we should not miss like that. Okay, so that's why consider all the functional groups as like suffixes only. So I am starting numbering from here 1, 2, 3. Only 3 carbons I have counted. Okay. Now what is the name of this compound is propane. So propane, 3 carbons are there. Propane 1 comma first position, second position 2 comma third position 3. Now I haven't counted aldehyde carbon, right? I haven't counted this. I haven't counted. If you observe, see propane only I am saying. These carbons are not counted from the aldehyde. So propane 1 comma 2 comma 3 tricarbaldehyde. What is the name? Tricarbaldehyde. Carbaldehyde. This will be the IUPAC name for the given compound. Okay, hope the discussion is clear. Or you can say 1 comma 2 comma 3 propane tricarbaldehyde, or propane 1 comma 2 comma 3 tricarbaldehyde. Both of them are perfectly correct. Okay, hope the discussion is clear. Right, let's move forward. Similar to these aldehydes, even in case of carboxylic acid also, if you are not counting the carboxylic acid carbon, then you should write it as carboxylic acid as a suffix. If you are counting it, you just mention it as oic acid as a suffix. Okay, like this. Okay, so these are the different functional groups we have. Okay, just make a note of it, and respect to prefixes and suffixes are mentioned here. Just go through them. If you have any confusion, let me know in the comment box. Okay, right. Let's move forward. So tell me, what is the priority order that we have discussed as per this question? See, this is a EPSET question, previously asked EPSET question. Now tell me, how can you answer? So I told you carboxylic acid first, then next sulfonic acids, Okay, like this, where do we have option? Carboxylic acid, sulfonic acid. Okay, next cyanides, or you can say nitriles. Okay, so this is 3. After this aldehyde 4, and least is hydroxy 5 as per the given data. So we have first option as our answer for the discussion. Okay, right. Let's move forward. Yeah. So how can you write the name for this? Yeah. So this thing we haven't discussed it now. I will tell you. So if benzene is there, so this ring is called benzene. What is this ring? This ring is called benzene. So we are saying about aromatic compounds now. So this is aromatic compound. So aromatic compound we can say benzene. Okay. So what is the formula of it? C6H6. What we can call benzene. So benzene is its common name as well as accepted IUPAC name also, IUPAC name also. Okay. If the benzene contains OH group like this, you should call it as a phenol. What you should say? Phenol. Okay, right. So phenol is also accepted IUPAC name. Okay, right. So to this phenol, at this position we have amino group, NH2 group, and at this position one methyl group is there. Okay. So now what I can write is amino. Amine means A comes first, methyl M, which is the first letter in alphabet A. So that is prioritized. So 1, 2, 3, 4, 5, 6. So what I can write? 3 amino first. You can write 3 amino, 5 methyl, phenol, 5 methyl phenol. What is that? 5 methyl phenol. So 3 amino, 5 methyl phenol. So option 2 is your answer for the discussion. Like this, you just try some questions from our discussion. Okay, you just try to name this compound. This is NEET question, but it is easier than the previous one. Okay, just try it. If you are unable to solve, I will explain them next. Okay, so this is also easy, you can answer. Okay, right. Let's move forward then. Let us start our discussion. See, there is a lot to discuss about IUPAC nomenclature, but whatever we discussed till now, I hope it is enough as of now, because we are conducting this as a bridge course now. So we need to have an overview of complete topics, right? So now you got some clarity on IUPAC nomenclature. The remaining things we will start once you come to the offline classes or in the online mode, wherever you join, there we will be discussing. Okay, so no worries about the further IUPAC nomenclature. So whatever we practiced, now you just go through them once again and solve some questions. Okay, now collect all your doubts and keep it with you. We will discuss once after you are coming here in the offline center. Okay, offline classes. Okay, right. Now here, see, the next thing is how can we understand the organic reactions? Okay, very simple. I will tell you, you just follow this organic reactions. Okay, so during an organic reaction, there are two things. What I am saying, there are two things. One is called electrophile. The other one is called nucleophile. What are the two things we have during a chemical reaction? One is electrophile, other one is nucleophile. I will tell you about them. So now what happens during the reaction? These electrophile, if I say, so the word you need to understand, electro means electron, phile means love, attraction towards electron. So electrophiles are having attraction towards electrons. Why they have attraction towards electron? Because they do not have electrons. They are less in electrons, that's why they are looking for the electrons to attract them. Okay, so I can say electrophiles are electron deficient species. What is this? Electron deficient compounds. Okay, species. Okay, what about nucleophiles now? See, nucleo, it means nucleus. Phile means love, attraction. So it has, nucleophiles have attraction towards nucleus. It means nucleus means positive charge now. Yeah, so they have attraction towards positive charge means they must be having negative charge. See, we know opposite charges attract each other, right? Opposite charges attract each other. This fellow is having attraction towards nucleus means it might be having a negative charge, that's why it is having attraction towards nucleus. That is how you can understand, simple. Okay, so these are electron rich species. What they are? Electron rich. So electron rich means what? See, electron has negative charge, right now? So nucleophiles have, these molecules or atoms or ions have more electron density, more negative charge on it. That's why they have attraction towards this positive charge nucleus, that is love towards nucleus, we can say. Okay, so now this is electron deficient and this is electron rich. Now what happens is, this electron rich fellow will try to donate the electron, and this electron poor fellow, that electron deficient fellow, will try to accept the electron. So that is simple. So this is donating, this is accepting. Then we are going to make a bond between this nucleophile and electrophile. That's how our final product will get something like, if electrophile is E, nucleophile is Nu, then there is a compound like this. So electrophile I am indicating with the symbol E, nucleophile as Nu. Now what I told you, so this electrophile has more electron density indicated with a negative symbol, and electrophile has, now nucleophile has negative charge, I told you. Electrophile is electron deficient, means positive charge. See, electrons are less, means positive charge on it. So this nucleophile will attack onto this electrophilic center, so that we are going to get a compound like this. Okay, let us do one simple reaction. Okay, let us understand it from very basic reaction here. So CH3Cl I am taking. Okay, so here I am writing one more thing as OH minus. What I am writing? OH minus. Now look at this, very simple ma. In the given compounds, in this given two fragments, tell me which is having negative charge. This species is having negative charge. Can I say it as a nucleophile? Yes, we can say nucleophile because these are electron rich. So you can identify the nucleophile here. That's it, done. Next, what about this? Yeah, methyl chloride I have written with a bond. Now just go back to the periodic table. There we studied about electronegativity difference, right? So halogens are more electronegative than this carbon, if you remember, right? So if these are more electronegative, what happens to the bonded sigma electrons? That is taken by the electronegative atom. What we discussed, electronegativity means if A and B is having a covalent bond between them, the tendency to attract the bonded pair electrons towards itself is called electronegativity. So if I say element B is having more electronegativity, it means what? That element B is having more tendency to drag the bonded electrons towards itself. So if it is dragging the bonded electrons towards itself, means atom B should get negative charge and atom A should get a positive charge. Okay, do not write complete charges, you write it as partial negative charge, partial పాజిటివ్ చార్జ్. అంటే పార్షియల్ అంటే అర్థం ఏంటి? ఎంతో కొంత ఎలక్ట్రాన్ డెన్సిటీ, మొత్తం ఎలక్ట్రాన్ డెన్సిటీ అనేది బి వైపు జరిగింది అని అర్థం. ఓకే, దట్ ఈస్ వాట్ పార్షియల్ చార్జ్ హియర్, పార్షియల్ నెగిటివ్ చార్జ్ అండ్ పార్షియల్ పాజిటివ్ చార్జ్. Here also carbon is less electronegative than the chlorine, so chlorine gets partial negative charge and carbon get partial positive charge. Hope up to here the discussion is clear. ఎప్పుడైనా గుర్తుపెట్టుకోండి, కెమిస్ట్రీలో ఎలక్ట్రాన్స్ని తీసేస్తున్నాం అని అంటే ఎక్కడి నుంచి అయితే తీసేసామో దానికి పాజిటివ్ ఛార్జ్ ఇవ్వాలి. వన్స్ అగైన్, ఎలక్ట్రాన్ని ఎక్కడి నుంచి అయితే తీసేస్తున్నామో ఆ తీసేసిన దానికి పాజిటివ్ ఛార్జ్ చేయాలి. ఆ ఎలక్ట్రాన్స్ని ఎవరైతే తీసుకున్నారో దానికి నెగిటివ్ ఛార్జ్ చేయాలి. సో chlorine is dragging the electrons, that's why I have mentioned negative charge here. Carbon is relatively losing some electrons, that's why I have written partial positive charge, right? Up to here it is clear, I hope. Yeah guys, if this is clear, mention clear. ఇది ఒక్కటి అర్థమైంది అనుకోండి, మ్యాక్సిమం మీరు రియాక్షన్ మొత్తం చేసేస్తారు ఇంకా. ఓకే, ఐ విల్ షో యూ హౌ టు డూ ఫర్దర్. యా, so look at this, what is the charge we are writing? Positive. See, a negative charge is there on this nucleophile and a positive charge in the carbon. So appudu em jarugutadante, this negative charge slowly come like this and will be attacks on this carbon. Why it is attacking? Because this is having positive charge, this is a negative charge, that's why it is coming and attacking here. అంటే ఏం లేదమ్మా, కెమిస్ట్రీలో ఎలక్ట్రాన్ డెఫిషియెంట్ సైట్ ఎక్కడుంది, ఎలక్ట్రాన్ రిచ్ సైట్ ఎక్కడుందో చూడాలి, వాటి మధ్యలో ఒక బాండ్ ఫామ్ చేయాలి, అంతే. అదే కెమికల్ రియాక్షన్, ఆల్మోస్ట్ డన్. అంటే అలా బేసిక్ అప్రోచ్ ఫస్ట్ రావాలి మనకి. ఓకే, ఇప్పుడు మనకు తెలియాల్సింది ఏంది? విచ్ ఈజ్ ఎలక్ట్రాన్ డెఫిషియెంట్ సైట్, విచ్ ఈజ్ ఎలక్ట్రాన్ రిచ్ సైట్, విచ్ ఈజ్ ఎలక్ట్రోఫైల్, విచ్ ఈజ్ న్యూక్లియోఫైల్ అనేది ఐడెంటిఫై చేస్తే ఆల్మోస్ట్ మన రియాక్షన్ అయిపోయినట్టు. ఓకే, ఎందుకంటే అదే బిగినింగ్ ప్రాసెస్ కాబట్టి. ఓకే, సో ఇక్కడ న్యూక్లియోఫైల్ అంటున్నాం, ఇందులో నుండి ఎలక్ట్రోఫిలిక్ సెంటర్ ఎక్కడ ఉందో గుర్తుపట్టాలి. సో ది బాండెడ్ ఎలక్ట్రాన్స్ అనేవి క్లోరిన్ తీసుకుంటున్నప్పుడు దీని మీద పాజిటివ్ ఛార్జ్ వస్తుంది కదా, సో దట్స్ వే దిస్ న్యూక్లియోఫైల్ ఈస్ యాడెడ్ ఆన్ టు ద కార్బన్. ఓకే, సో అప్పుడు ఏం జరుగుతుంది, వెన్ దిస్ నెగిటివ్ ఛార్జ్ ఇస్ అటాకింగ్ హియర్, సి వీ నో కార్బన్ హ్యాస్ మ్యాక్సిమం valency as 4 tetra valency we say right now. So tetra valency already 3 bonds here, this is the 4th bond. If this OH is also coming, that becomes 5th bond. We cannot place 5 bonds now. What happens, one of this old bond will get broken. So అంటే ఈ క్లోరిన్ ఇక్కడ నుండి తీసేసాం అనుకోండి, ఈ 3 bonds అండ్ ఇది ఒకటి కొత్తగా 4 bonds, అలా we are going to get our final product something like this, CH3OH. Okay, what is happened here, chloride ion is removed, hydroxide ion entered in right now. So now how this chloride ion coming out as a Cl minus. Okay, chlorine coming out as a Cl minus. So now దీనికి ఒక నేమ్ ఉంటుంది అన్నట్టు, వాట్ ఈస్ ద నేమ్ ఆఫ్ దిస్ రియాక్షన్ అని అడుగుతారు. సో ఇప్పటికైతే అర్థమైంది కదా, వాట్ వి డిస్కస్, వన్ క్లోరైడ్ ఈస్ గోయింగ్ అవుట్ అండ్ OH minus ion is coming in. Okay, so this is how a chemical reaction taking place. So what you did here, you have prepared methanol, what you prepared an alcohol from alkyl halides. Methyl chloride నుంచి మీరు మిథైల్ ఆల్కహాల్ని ప్రిపేర్ చేశారు. హౌ సింపుల్ ఇట్ ఈస్. ఓకే, సో బేసికలీ యూ నీడ్ టు ఐడెంటిఫై న్యూక్లియోఫైల్ అండ్ ఎలక్ట్రోఫైల్, మేక్ ఏ బాండ్ బిట్వీన్ దిస్, దట్స్ ఇట్. ఓకే, దిస్ ఈస్ ద థింగ్. నౌ వాట్ ఈస్ ద name, what is the name of this reaction, what is the mechanism name here we used here అనేది ఒక క్వశ్చన్. See what I told you, a nucleophile is entering and another thing here, Cl is going out as a Cl minus. So Cl minus charge ఉంది కదా, so that is also nucleophilic only na, electron rich only na, so you can also say this is nucleophile only. Okay, so one nucleophile is replacing another nucleophile, something like when we are playing a game, one player enters and other player will be removed, like we will be saying him as a substitute player na. So here also one nucleophile is substituted by another nucleophile, so you can simply say nucleophilic substitution. What is that? Nucleophilic substitution reaction. What is the name of this reaction? Nucleophilic substitution reaction. Okay, and it has further classification like SN1, SN2, all this we will discuss about that, but here whatever we discussed, it is clear right now. Yeah, let's move forward then. Yeah, so nucleophilic substitution you have got some clarity on electrophile, nucleophile. Let us give one or two examples on this so that you can identify. See, how can you identify an electrophilic center? How can you identify electrophilic center? First of all you should be clear with this. How can you identify electrophilic center? See, I told you, if there is electron deficiency is there, you can mention it as electron deficiency is there, you can mention it as electrophilic center. Okay, let me give you one example. See, carbon has tetravalency, we know. When it is having tetravalency, how many electrons are there in this? See, 1 bond, 2, 3, 4. So 4 bond means 8 electrons are there. Okay, so whenever there is 8 electrons in the 2p series elements, like generally octet rule configuration is there, means they are having electron sufficiency. But sometimes what happens, you know, they are having electrons lesser than the octet. For example, here I am writing carbon with only 3 bonds, and one positive charge. Sir, how we are writing this positive charge? Again look at this. See, I have mentioned it like this, CH3C means 3 hydrogens, 6 electrons, 3 hydrogen means 3 bonds now, 3 bonds with the carbon, each bond 2 electrons, like that 6 electron, this is 7th and 8th electron. So now what I am doing is I am removing this chlorine with the 2 electrons, along with the 2 electrons. Who is losing the electron now? Carbon is losing now. When it is losing, it should get a positive charge. It should get a positive charge like this, CH3 plus. So now the species here generated having only 6 electrons. How many electrons it has? Only 6 electrons. Now it has 6 electrons now. You should call it as electrophile, particularly carbon with positive charge now, carbocation. What you should call? Carbocation. So carbocations are electron deficient species, which we can call it them as electrophiles. What they are? Electrophiles. Now let me explain you one more thing called a nucleophile here. Nucleophile. Okay, so nucleophile means same carbon having tetravalency, like CH3 is there. So here what I am doing is, previously some group G is there. What I am writing? Some group G is there. So now the bonded electrons, instead of giving to this G, I am giving them to the carbon only. I am removing G as G plus. So who is losing the electrons now? G is losing, the group G is losing the electron. Now the bonded electrons are staying with the carbon only now. So now what is the charge we are getting on the carbon? CH3 minus. So you can say this as CH3 minus as methyl carbene anion. What you should say? Methyl carbene ion. Like this you should call. Okay. Now see what is the charge we have? We have a negative charge in the carbon now. So you can say this as electron rich species or more electron density containing species, which is nothing but our nucleophile. Okay, like this. If electron richness is there, nucleophile. Deficiency, electrophile. Okay, that's it. Yeah. Yeah. So now let us do one thing here. CH3, CH double bond CH2 is there. So to this I just want to add H plus. So H plus is electron deficient or rich? Electron deficient. Why it is deficient? Because no electrons in this proton, I can say simply. So to this deficiency I can donate the electron from this compound. But where do we have the electron donating capacities? Yeah, here, this pi electron, because sigma bond and pi bond is there. So pi bond is weaker bond compared with the sigma bond. So that's why these pi bonded electrons can be donated to this H plus. If we are donating that, we are going to create something like this: CH3, CH, CH2 and a hydrogen atom over here. Like this you can create. When it is donating the electron, who is losing that pi electrons? The electrons are present between two carbon atoms, but the both carbon atoms are shifting like this, means the newly added proton is on the terminal carbon, means this electron, and here the central carbon is losing the electron. So you can write here positive charge. Whoever the atom losing the electron, mention it as positive charge like this. Okay, so what is that? I told you carbon with positive charge is called as carbocation, I told you. Okay, right. So if there is any other negative charge, that can be added over here. So generally the reaction will be given like this. They will be giving the reaction like this. To the compound, they will ask us to add HBr. So HBr, we know HCl, hydrochloric acid, is an acid. Okay, HBr is also an acid, HI is also acid, but which is stronger acid means, generally what we think, hydrochloric acid is strong acid. Yeah, this is strong acid, but as we move down the group, that acidic strength further increases, so this will be more acidic than the remaining things. So what is the acidic nature? So HCl lesser than HBr, lesser than HI. Okay, so HBr now, acid only now, strong acid only now. Yeah, so now it releases H plus ion and stays as Br minus ion. So first what happens is, this H plus ion is given to this, so that we are going to get something like a carbocation that we have written, positive charge. Next what happens is, this negative charge is added over here on the carbon, positive charged carbon. So there you can get CH3, CH, CH2, already CH2 is there. Now one more you have added here, no? Yeah. So you added here, so Br comes here, like this you can get. Okay, wherever positive charge is there, there we are adding this. So during the reaction, whatever the carbocation site that you have seen here and here, both of them are same only. Here separately I mentioned, here combined form I mentioned. Okay, so now the carbocation formed is called intermediate during the reaction. What is that? Intermediate during the reaction. What it is called? Intermediate during a reaction. So now once again look what happening here is, generally when you write organic reaction, there is something called reactants, and here products. What I am writing, reactants gives rise to products. During this conversion from reactants to products, we might use some specific conditions, like some temperature we will be mentioning, suitable conditions. Some reaction required some atmospheric pressure, also adjustment required. Okay, that conditions whatever we are taking for that particular reaction mentioned on the arrow mark. Along with these conditions, sometimes we may use catalyst also. So what is the use of catalyst? That will alter the rate of a reaction. It means it increases the reaction or decreases the rate of reaction. Okay, depending upon the requirement, we may use a positive catalyst or a negative catalyst. Okay, so that catalyst you mentioned here, catalyst. Okay, right. Yeah, and during the reaction we will be using some specific conditions. I mean specific conditions already mentioned, but solvent also used. అంటే ఒక రియాక్షన్ జరగడానికి కొన్ని సాల్వెంట్స్ అనేవి యూజ్ చేస్తాం అన్నట్టు. సో ఆ సాల్వెంట్స్ని ఏంటి అనేది కూడా ఇక్కడ మెన్షన్ చేయొచ్చు. ఫర్ ఎగ్జాంపుల్ మనం సబ్స్టిట్యూషన్ రియాక్షన్ చేస్తున్నాం అనుకోండి, దేర్ విల్ యూజ్ సమ్ టైమ్ ఎసిటోన్ ఆర్ డిఎంఎఫ్, డైమిథైల్ ఫార్మమైడ్, ఆల్ దీస్ థింగ్స్. సో యూ కెన్ మెన్షన్ ద catalyst as well as solvent also here, so that whatever the conditions required you are mentioning above and below of that arrow mark. Okay, once again, this reactant side we have two things. One is called substrate and the other one is called reagent, or simply you can write attacking reagent. So the name itself saying this is attacking reagent. So this fellow will attack on the substrate. Okay, and here during the reaction sometimes some intermediates are formed, intermediate, or we can also say this as a transition state. Sometimes there is a transition state formation and finally gives you products. Along with the products, some byproducts also formed. Okay, byproducts also formed. Like this you can understand. Okay, yeah. So here in the previous reaction that I have mentioned, CH3, CH double bond CH2 and HBr. So our substrate here is alkene and HBr is a reagent. Okay, and we have a carbocation formed as an intermediate like CH3, CH, CH2. Like this we have seen one intermediate. Okay, finally addition of further negative charge given us a product. Okay, so products might be something like major, minor products will be there, so that you can write that side. Okay, hope the discussion is clear. So now what is this type of reaction? Which type of reaction here? So first we added H plus ion. So H plus is an electrophile. So electrophile is adding onto the molecule. See, we just added, we have removed nothing from the substrate. To the substrate we just added, but in the previous case, that substitution case, we have added one thing and removed the other thing. So that is called substitution. Here we are adding on the like substrate. Now you should call addition reaction. What is that reaction? Addition. And particularly you are adding electrophile. Okay, so electrophilic addition reaction. What is this reaction called? Electrophilic addition reactions. Okay, so you have studied about nucleophilic substitution reactions and electrophilic addition reactions today in this class. Okay, like this we have something like, first let me give you the names. Reaction types. Reaction types are addition reactions, substitution reactions, next elimination reactions. Elimination reactions. Okay, the short form you can make. So these addition reactions, again electrophilic addition reactions, nucleophilic addition reactions, and one more thing is called nucleophilic addition reaction, one more is called free radical addition reaction. Okay, see here in the substitution also, electrophilic substitution reaction, nucleophilic substitution reaction, and free radical substitution reaction. Okay, this many types of reactions are there, and elimination reactions are also there, like 1, 1 elimination, 1, 2 elimination, or alpha beta elimination, and like this we have. Okay, up to here it is clear, and one more is there, it is also important, E1 CB elimination also there. Okay, so all these things we need to discuss, but I hope you got some clarity on substitution, what exactly mean by substitution, what exactly mean by addition from the last two examples. Okay, right, the remaining things whatever we have will be discussed in the next sessions. Okay, and the complete explanation of these reactions will be provided during the class, because if I start discussing about each and every reaction, that requires almost some 10 days for completion of reactions with some better good examples. Okay, yeah, so anyways you need little more explanation about the organic reactions, how can we use some tricky ways, all these things. Okay, once you are coming to the offline center, we will be starting discussing about all this, but I hope you got some clarity on what type of additions and substitutions we have. Okay, right, so the remaining things will be discussed in the next session. Please stay connected with our NEET World YouTube channel. If you have any confusion, please write in the chat box, and yeah, you can directly reach us to the mobile number provided in the description to discuss further about our new batches and when we are going to start the NEET long term, JEE long term, as well as the fresh first year and second year batches. Okay, so thanks for watching, stay connected.